Okay. Hello, everyone. How's it going? Everyone enjoying DevOps UK? Come on, that's not very enthusiastic, is it? Is everyone enjoying DevOps UK? Yes! Fantastic. So I think beer kicks off in like an hour, so this is like the nice, friendly, have fun conference talk slot. If anyone's watching at home on parlays, there are people in the front row eating popcorn at the moment. Looking forward to fun. Okay, cool. So, my name's Richard, and what am I going to be talking about? So first I'm going to tell you a little bit about the motivations on this talk, kind of why you might want to care a little bit about the differences, and more interestingly, actually, similarities between functional and OO code. And then we're going to go through a couple of kind of things which are kind of well established as good coding practice ideas, concepts in the object-oriented community, so solid principles, and a couple of design patterns, and going to talk about how there are kind of equivalent concepts or things that are doing the same kind of overall job in the functional world. And then I'm going to talk a little bit about anthropology, by which I mainly mean show pictures of Arnold Schwarzenegger. So that's going to be entertaining. Okay, so I guess the thing is that, to me, a lot of discussions that you see on the internet, has anyone read those kind of discussions on the internet, where it's like two guys who are just like this? They're both looking at each other, and not face-to-face because it's on the internet, but they're pretty disgusted with the other person's opinions or physique, or, you know, not very friendly. They're not really very sympathetic towards their perspective, especially around functional and OO code. Anyone familiar with that? A few people nodding, a few people nodding. You can say yes. You can say yes. So there's some good quotes on this kind of thing. So object-oriented programming is to writing a program what going through airport security is to flying. Kind of a bit of a negative comment on the verbosity, that kind of thing. As Java developers, I'm sure we're all familiar with those ideas. And this guy's got a great one here. TDD replaces a type checker in Ruby in the same way that a strong drink replaces sorrow. Anyone got a friend who's a Ruby developer? Anyone got a friend who's a Ruby developer who's an alcoholic? There are still some people with their hands up after the second question. On the other side, you know, there's a lot of perspective that the functional programming community is a very elitist group of people. So brain explosion is a traditional pastime in Haskell, the IRC channel. And also the idea that kind of a lot of times when you see functional programming, people talk about things they want to push everything into a functional pattern. So someone had a good quote here saying, some people claim everything's a Lisp. One time I was eating some spaghetti, somebody came by and said, hey, nice Lisp dialect you're hacking there. It's not really great, is it? And I guess I'm here to kind of talk about how we can be perhaps a little bit more better off together, perhaps how we can take some of the ideas from both programming communities and see what we can make of it. I mean, obviously, most of this is stimulated by the release of Java 8, bringing some more functional ideas into a very popular OO language. But also, you see a lot of the newer languages being hybrid, having some kind of common features. Talk about that a little bit at the end, but yeah. I think the other caveat to say about this talk is that there are some of the more traditional OO definitions, which I'm reinterpreting a little bit and taking a slightly different perspective on. So, you know, a caveat that we're going to be a little bit unorthodox for some of the definitions. So, let's kick that off by talking about some solid principles. So, who's familiar with the solid principles as things? Nearly everyone. Fantastic. Anyone confident enough to name all 5 of them? Oh, there's one. Go for it. Cool. Okay, yeah, that's the third.
Interface segregation.
Yep.
Open-close.
Yep.
Dependency inversion.
Fantastic, fantastic. Big round of applause to that guy for getting all 5 and, more importantly, having the balls to do it. Okay, cool. So, yeah, they're basic object-oriented programming principles. I don't need to tell you this because when I asked you if you were familiar with it, you all said yes. They aim to make programs easier to maintain. So what we mean by that is allowing you to change things without, you know, shooting yourself in the foot. And they're also kind of guidelines to remove code smells. Code smells are kind of familiar, a concept that we're all familiar with. The idea that you kind of see something and it looks like, ooh, that's a bit nasty, isn't it? I was giving this talk in Italy a few months ago. The Italians are fantastic on the language front. They pointed out to me that the word for smell in Italian was puzza, which has a fantastic ring to it. So if you're ever disgusted with some code, look at it and shout, puzza. Okay. Right, so single responsibility principle. Each class or method should have a single responsibility. Sounds simple, sounds like it's the kind of thing that we should all be doing. The definition for single responsibility that's picked up in usage is a reason to change. So decoupling things from each other which want to change at different times and keeping things together when they should be kept together. So another thing I've seen a lot of is people ignoring the fact that SRP also means that it should only be that one class that you need to change for that responsibility, that they also involve some encapsulation as well. So here's a perhaps alternative way of viewing a single responsibility principle. So here's a very inefficient and slightly ugly block of code that counts the number of prime numbers up to a certain number. And when you see that code, that's the facial expression that you should be making. It's okay, I was looking out into the audience, there were a few people like that and a few people like that. So an obvious refactor that people might make is pulling out a single method, which is one way of separating off different responsibilities there. But something that's kind of perhaps something that people don't think of when they're thinking about responsibilities is one of the other things about your program that you might want to change, which is your threading model. So this is code that delegates to the Streams API in Java 8. I don't know if anyone went to Paul's talk earlier, or anyone went to Venkat's talk earlier. So some people should be vaguely familiar with the Java 8 Streams API features. Cool. So that's code that's doing the same things on the previous slide. And the interesting thing here is, okay, this is still sequential code, but if I want to change it to run in parallel, I can very easily flip this by just plopping a .parallel call somewhere into those pipelines. So another thing, responsibility to think about, which we perhaps not thought about, is the threading model. And writing more functional style code, similar to the Streams API, is one way you can get there, one way you can have an opportunity to decouple your code from your threading model. Another thing to think about is how that gets enabled in Java 8. And the way it gets enabled is with a bunch of higher order functions. So a higher order function is a function that takes another function as an argument or returns a function back out. And that means you can have APIs which gets nicely parameterized by having different behaviors that you can pass in and allow you to encapsulate some of that threading model responsibility down lower in your class hierarchy rather than having it spread out throughout your whole application. And yeah, the single responsibility principle, in my opinion, does require the ability to be able to pass around behavior. So, especially at this level. Yeah. So the next principle is the open-closed principle, which means that you can talk to people who are in jail even when you're not in jail. Originally defined by Bertrand Meyer as software entities should be open for extension but closed for modification. Is anyone aware of what Bertrand Meyer's original book, which is written in like 1988 or so, was talking about when it was covering open-closed principle? One guy at the back? When you get, that's probably accurate. I've read a few things written by Bertrand Meyer, and a lot of them turn into an Eiffel tutorial as you get along through them. What he's actually saying was, he had this kind of interesting concept, which I don't think really holds water in 2014, but especially post-agile, iterative development, that kind of thing. But he had an idea that you should write a class, and once the class was finished, again, not really a concept which is standing the test of time there, you should subclass it. So you should never modify the original class in order to add actual behavior. That sounds crazy, right? You'd never do that today. Even the idea of a class being finished or done is a bit weird, right? You never know when some other stakeholder is going to come in and say, nah, we need this other change. Some new regulations happened. Some new users want this feature. It's crazy. So we've kind of redefine the open-close principle. So let's look at an example to illustrate the point. Suppose you're writing some code that graphs like basic hardware metric data. So, I don't know, split between user system time on a box or amount of time you're spent doing disk I/O versus CPU time, that kind of thing. You may well write that naively by just encoding all of the concepts into your code, that all the different graph types you want. But open-close principle is generally interpreted these days as a call for polymorphism. So if you're writing said code, you depend upon some abstraction that represented your series of metric data, and you'd have various implementations of this abstraction that all provided different series of metric data. So you could add a new series of metric data without changing the class that you're calling. And that's the way it's kind of become reinterpreted. Of course, another way to interpret the open-close principle is a call for more higher-order functions to sit around your code. So Java 8 has a function called thread-local with initial, which is a higher-order function that lets you create a thread-local variable. Are people familiar with thread locals? Most people are familiar. Okay, so if you're not familiar with thread locals, the thread local variable is a variable which is an instance where you have a different instance of that on your given thread. And it takes basically a factory function that generates your value. So I've added in an initializer for the called simple date format. You'd think that formatting a date is the kind of thing that wouldn't have concurrency bugs, because you're formatting a date, right? But unfortunately, it does have concurrency bugs, and if you're formatting two different dates at the same time in different threads in Java, you can get half of the date from one thread and then half of the date from the other. Or even worse things, which are totally confusing. Fantastic bug if you ever see that and go, what? What? And then you can just use it by calling it. But what's interesting is this with initial is a higher order function. So again, it's providing you something which you don't need to change the behavior of, something which is closed, but which is still open for modification by passing in different behaviors. So there's another use of that same function which provides you a completely different thread local variable, in that case a thread ID variable that just uses an atomic integer which you can increment and pull the values off. Another approach, more taking some more functional ideas over, is viewing the open-close principle as a call for more immutable data types. So who's familiar with the concept of immutability? Okay, cool. So immutable objects are objects which, once created, never get modified. And one of the interesting things about that is you're perfectly safe to add in different behaviors and methods associated with that class, which are pure functions and only depend upon the immutable object, because you know that introducing those things as you evolve the class over time won't break the underlying other uses of that object which are already in place. So it does, in another way, is another interpretation of the open-close principle that fits a more functional worldview. So, the Liskov substitution principle means let Q of x be a property provable about objects x of type t, then Q of y should be true for all objects y of type s, where s is a subtype of t. I'm sure that's what everyone's face is looking like when you see that principle lying around. What, kind of simplified, but what you're really getting at is a subclass behaves like its parent. That's what we're trying to say something of. And you can pull out a few different properties of this. So where the parent worked, the child should. Where the parent cause an effect, then the child should. So your preconditions hold, your postconditions hold. Where the parent's stuck by something, the child should. So where you maintain some invariant, the child class doesn't do. And also don't change things in your system that your parent class did. Interestingly enough, if you look at all those principles and think of the relationship between real parents and children, children do the exact opposite in all four cases. A more functional perspective on that kind of thing is that a lot of the time when people model things in a kind of functional world, they don't use the inheritance approach to things. And the Liskov substitution principle, a lot of that, what that's about, is saying if we have this parent-child complicated inheritance relationship, you need to follow this set of rules. And another approach to that whole area is saying, don't do that so often, or don't do it where it's not appropriate, and you don't need to worry about those big 4 rules. In fact, that idea has seemingly wafted over from functional programming so much that you get a lot of people saying, using the composite reuse principle, or compose, don't inherit. An idea that leaves you with a much simpler relationship between objects and doesn't bring up some of the other problems that you might have with complicated inheritance relationships. The next principle, the I in solid, is the interface segregation principle. So-called Uncle Bob, he's not my uncle, defines this as being dependency of one class to another one should depend upon the smallest possible interface. So let's have a think about what that means. So say we've got some kind of factory going around, a factory like an assembly line, that kind of thing. And this factory depends upon some workers which you're going to use in the system. Our workers have 2 basic operations. During the day they work, and at the end of the day they go home, they do something else. Now, our assembly line requires multiple instances of workers. There's an assembly worker and a manager object. The manager has a very simple work function, which mainly involves shouting at other workers and not doing any real work. Now, at some point in time, your factory evolves and the factory starts using some kind of robot, right? The robots don't need to go home. You've realized that you've hit a point where the interface you're depending upon, the abstraction isn't quite right for what you need to do with it. So the kind of interesting thing, I'll get to the kind of more functional perspective on things, but I guess what this is really an artifact of is an artifact of nominal subtyping. Who's familiar with the difference between nominal and structural subtyping? A few people. Fantastic. What we mean when we say nominal subtyping is if you've got classes called foo and bar, and you want to establish a parent-child relationship between them, you need to have an explicit named relationship. So foo needs to say, so in Java syntax, foo needs to say extends bar for it to be a subtype, for it to be a subclass. So it might say implements bar if it's an interface. And these relationships are entirely explicit, and they're based upon the names of those types, which is why it's called nominal subtyping. So you see it a lot in statically typed OO languages, so Java, C++, C#, loads of things which are in that vein, should we say? And so if we look at a concrete example of this, we've got our assembly worker, we say implements worker, manager has to say implements worker, robot has to say implements worker. And when we want to actually use these guys, our add worker method needs to take a variable of type worker. Okay? There is another alternative to nominal subtyping, which is why it's a valid concept, right? It's not the only choice in that spectrum, even though it's, as we've shown through the show of hands, it's not necessarily that well known or popular. So structural subtyping, or who's heard of structural subtyping? I don't know why I've asked this question, now I put it on this slide, you should all put your hands up, right? Who's heard of duck typing? A lot more people. So duck typing is like the kind of dynamically typed variant of structural subtyping, or without being too controversial, I'm sure someone's going to come and kill me for saying that, but that's roughly a right statement. So the relationship between types is implicit and based upon the shape of that class. So in an OO language, this means the fields and methods that it exposes. For functions, it might mean the signature of that function. What this means, if you've got some object and you want to call getFoo, then object doesn't have to be an instance of a type that declares a getFoo method. It just needs to declare a getFoo method. That object variable doesn't need to be declared to be a type. Just the object needs to have the method. So as I mentioned, Ruby is like a duck type language, kind of well known there. But there's also a bunch of other programming languages which have some elements of structural subtyping. So a lot of the ML family languages and OCaml have it. Go has it to a certain extent. You can do a bit of both. The templating system in C++ has a kind of concept of structural subtyping in terms of the way templates work. And yeah. So it is used, not so much. C++ templates are incredibly complicated for other reasons, but structural subtyping is a thing. So for looking at our example, all we really need to do is, instead of saying we implement anything, we just have to have a work method that takes the argument that it needs. And so this is actually a Scala example. So Scala doesn't technically implement structural subtyping. It has like structural type refinements, but I'll wash over the difference there for a moment. So what this is saying here, this is a type declaration that says our worker variable is some object that has a method on it called work that takes a single argument that's of type production step. So this is a way of saying something about the structure of that parameter rather than a concrete type. Now, I use Scala as an example because I think it's a syntax people are quite familiar with. If you're using a language that has structural subtyping, but instead of having local type inference like Scala has, it has global type inference like something like OCaml, you can just write things like this, where you just have a worker, and your compiler will figure out the rest for you. It'll figure out what's needed. And it's a similar kind of situation in dynamically typed language, in a duck typing situation. Java 8 has a kind of interesting spin on this, where Java is very much a language with nominal subtyping all over the place. And you can't just throw out how many years of history in one go. So Java 8's got a concept called a functional interface. So a functional interface is an interface with a single abstract method. And they're used as the type of Lambda expression. So anything that's a Lambda expression has a type that's a functional interface. I was going to say, given we started off talking about interface segregation principle, this is, by definition, the minimal interface that you can have because it's only got a single abstract method to depend on. The interesting thing about the way things like method references and lambdas work is whether they type check correctly depends upon the structure of the lambda, so the signature of your lambda, or the signature of your method reference. So this is a kind of very limited way of introducing structural subtyping into Java. I'll show a different example which makes use of this later in the talk. So just some thoughts on interface segregation principle. If you've got a structural subtyping relation, then it's another one of those things you don't need to worry about. I mention it in a functional context because, as far as I can tell, nearly all languages which are functional, or maybe even all languages which are functional, go down the structural subtyping route. And Java 8 has this kind of more hybrid setup. The functional interfaces provide you a nominal structural bridge. Oh yeah, and one more thing. I did mention, depending on the middle interface, I've seen people justify implementing like a frickin' million interfaces when you see code. That's not what the interface segregation principle was originally about. Okay, cool. So the dependency inversion principle means men can have babies. It's there on a slide, it's a fact. What the dependency inversion principle really means is abstractions should depend upon details, details shouldn't depend upon abstractions. So the goal here is to kind of decouple your glue or decouple things which aren't central from your business logic. Now, one of the most common uses of the dependency inversion principle that you see is the inversion of control, so DI containers. That's not the only way the dependency inversion principle can happen, but that's something that you see a lot in people's code. So it's interesting that there's a lot of use of the dependency inversion principle in the streams library. So here's an example that takes an album and finds all the musicians. Well, what it does, it gets all the musicians from an album, finds the musicians who are bands, which are musicians with names that begin with the word the, right? That's a band. gets their nationality, and finds a list of all their nationalities. And code that uses the streams library is actually a great example of another approach to the dependency inversion principle. So here, this code isn't depending upon specific operations on that, on like a list of musicians or anything. It's just taking these higher level of abstractions, filter, map, collect, things, operations that have names, things which are higher level concepts, and it only depends upon those concepts. It means you can change arbitrary stuff in here. Maybe that musicians should return a stream that's coming from a linked list. Maybe it should turn something that's coming from an array list. Maybe it should not be anything like that at all. Maybe it should be running in parallel. Who knows? By depending upon these abstractions, you're decoupling away that kind of craziness. So here's some code which is in dire need of refactoring. So this is some code that takes a file and finds all the lines of the file which are headings, so some kind of text file. So we open a buffered reader from the file, and some streams code that takes the lines from that file, filters out the ones which are headings, and returns the list. Now, unfortunately, we've got our kind of basic business logic here, which is get the headings and give you a list. And we've also got all this glue code lying around. Now, an interesting approach that you can sort of do, a more functional approach to resource handling, is using what you might term the execute around pattern. So instead of worrying about all that file I/O, open, close, all that kind of stuff, here's what we can do. We can have a function called withLinesOf, which is an abstraction that we're going to depend upon. It takes a file as its first argument, so that's the same file field that we had in the previous example. The body of this withLinesOf is a lambda expression that takes the lines of a file and returns you some object at the end, so actually we're collecting to a list. And at the end, we're going to take our I/O exception and convert it into some nice domain-relevant exception, so you couldn't look up all the headings, okay? And the way you implement that is the code that calls it looks like this. So again, you pull your I/O code down here, and we've built an abstraction that's just a method, not a class, not anything complicated, just a method, just something simple. And that's a much more kind of functional approach to resource handling, where things that you want, which are details of your application, get passed in as functions. It's also another example of a higher order function. Okay? So on the dependency inversion principle, we mentioned that a kind of form of inversion of control, which people don't really talk about that much, is really higher order functions. When we say abstraction, that doesn't necessarily mean an interface or an abstract class. That can just be a method, it can just be a concept, it can just be something you're delegating to. And things like that withLinesOf method, you see a lot of that kind of idiom in functional code. So there's a function called in the Haskell core library called withFile, which takes a callback, and that's what you do with your file, and then it gets closed up afterwards. Okay? So I guess the kind of key point I was trying to make there was that all the solid pattern, all the solid principles have some kind of equivalent idea in functional programming. Something's kind of doing something similar or the same idea. But it's expressed in a different way, and it can also be used differently, different code, that kind of thing. So let's look at a couple of design patterns now, and I'm just going to have a look through them and show you how we can make something that's a little bit more functional or a little bit more lambda usage, which implements the design pattern a bit differently. So the command patterns are really it's a kind of classic gang of four design pattern that you see around. And there are four things involved. There's a receiver, which does the actual work. There's a command, which is a way of bulking up something to be done on the receiver. There's an invoker, which controls how all these commands get put together. And then there's a client, which deals with wiring everything together. So a concrete example of this is, say, you're recording and writing macros. A macro is something that takes something that's very long and makes it very short. Okay. So your editor is the underlying object which performs this editing thing which you want to bundle up commands about. You have some kind of command interface. It's called action here, which bundles up those things. You've got a series of concrete command implementations. So here's the open command, and it takes in an editor and delegates to its open in the perform. And you need n of these where you want n different operations that you can save. Your macro object itself stores a list of actions and recalls them by saving those actions in the list, and then when you want to run it, it just runs each action in turn. And your client code looks like this. You want to record a macro, we plop a few operations into it, and then we can run them all at the end. Now, the interesting thing about the command pattern is that that command object is a function. If your language supports first-class functions, if you're happy with that idiom and familiar with that idiom, you don't need to have that whole n series of boilerplate classes just to call those functions. You can just call the functions directly. So here's some Java 8 code that just takes lambdas in and just directly invokes open, save, or close on the macro. The observer pattern is another design pattern which we can have a look at. So one of the interesting, so an observer has some kind of interface where things get notified. So has anyone done some kind of like swing programming at some point in time? Yeah, it's okay to put your hands up, guys. You're in familiar company. We've all had that pain. We've all had that suffering. It's okay. It's going away. It's gone away, right? You don't do it in your day job. Anyone still do it in their day job? Well, maybe people did and just were too embarrassed to put their hands up. It's okay. It's okay. We feel your pain. So there's notify on the observer, so you get informed when some event happens. Also, it doesn't have to just be UI programming. It's the kind of thing which lets you decouple events and listeners from underlying sources of information. And then your subject maintains a list of these observers and notifies them whenever something happens. You have multiple implementations. Easy peasy, common. We've all done it at some point in time. So here's a concrete example, is a profiler. So a profiler is getting updated with information. It's a sampling profiler. Every time it samples the user's application, gets a dump of the threads, stack traces, and it forms some kind of UI, which may be recording to a file, it may be a UI, anything you want. So something that listens to profiles has got an interface. So that's your observer interface. And every time we want to implement a subject for these things that pushes data out, we need to implement some kind of boilerplate code. A list of listeners, something that adds to a listener, maybe something that removes from it as well, and something that accepts all these guys. It's amazing how much of this boilerplate code you see if you look at like a library that's done a lot of observer patterns. So if you look at swing internals, this kind of thing you see all over the place. And the interesting thing is, all of these things, all these observers have the same functional type, right? They have some argument they're taking, and they're not returning anything at all. Previously, you had to write this every time, but we don't want to write this every time. So one observation that we can make is Java 8 has this interface called a consumer, okay? Which... Sorry, these type signatures are all the wrong way around. That should be T goes to void, profile goes to void, action goes to void. So, our consumer, our profile listener, and even the action listener interface from Swing all have that same signature, that same structure. And we don't want to have to write that massive boilerplate every time we want the observer pattern. But we can't do that previously to Java 8 because we would need to have... There's no common parent type amongst these guys. There's nothing for us to abstract over. There's no name for us to invoke and call. But you can write something like this now. You've got a listener, which takes some kind of consumer of T. T is the argument type that you're going to be observed, the event type that you will be observing. When you get a new event, you push it out to all the consumers. And you just add a consumer in like this. Pretty simple. All he's done is made it generic, you're saying. But in your client code, you can write stuff like this. So these guys here, this flat model and this tree view model, don't implement consumer of profile. They implement profile listener. They implement another type which has no nominal relation. And by taking this more modeling around a more structural subtyping kind of approach, we have the opportunity to allow those guys to fit in, because these method references, a bit like lambdas, have the characteristic that they type check based upon the structure of the type rather than the name of the type. So this allows you to write a generic subject and have things of different interface types plugging into it, which you've never been able to do before. So that's another kind of design pattern which you're able to make a little bit better by taking some of those ideas which you've seen a lot in functional programming languages. So I guess one of the things you hear a lot as well is when people talk about, especially coming from a functional perspective, that design patterns are rubbish. Design patterns need to be thrown away. You just need a new library feature, right? That fixes all the problems. Seem to be all over the internet. But I don't really think they need to be thrown away. I think what people really mean is they've got their own way of doing a design pattern that perhaps works a bit differently in their language, and you could improve it by doing it a slightly different way. I think that's a more accurate statement. Okay, so let's talk about anthropology. So an observation that I have to make. Oh, sorry. Yeah, go ahead.
Is that a new keyword, provide, on one of the previous? I haven't seen that before. On that provide.
Provide?
Profile listener provide. Method name? Or is that a method name?
Sorry, profile?
No, I was wondering about provide list. First line. Yeah.
Ah, no, that's not a new keyword. That is poor color highlighting on my behalf in the slide. Provide is just a method, as in, so have you used like providers in Juice or in a DI container? So an object that wires up other things, a provider, like a kind of factory that gets injected and then gets you a new object, that type of thing. So that's what provide is doing there, but it's not a new keyword now. Okay, but thanks for that question. I'm glad one person is at least reading the slides. Cool, thanks. So yeah, what was I going to say? Anthropology. So an observation I'd like to make is that programming language evolution, the progress of it at any rate, follows the career of Arnold Schwarzenegger. It's a fact. It's a fact. In the 1980s, everything was fantastic and great. The 1980s in Arnie's career, he was having box office hit all over the place. Everyone loved Arnie, especially the film Twins, which is actually thematically relevant to this talk. In the 1980s, there was a huge amount of kind of progress on programming language side of things, programming language implementation as well. So a lot of people talking about polyglot programming, a lot of polyglot programmers, and also languages which are coming through, kind of being used a little bit more in the 80s. 80s also has a big Lisp popularity, a big Lisp boom, and a lot of people, even in Lisp, the archetypal functional language to some people, has its own object system. Even Smalltalk 80, the archetypal object-oriented programming system, has Lambda expressions. You look at the way they're kind of equivalent to the collections library works, modeled in a very functional way. People going very multi-paradigm. Fertile language research, huge amounts of work done on GC, on early JITs. Crazy progress. In the 1990s, everything goes wrong. Arnie's in awful films like Jingle All the Way. This is terrible. Don't ever watch this film, okay? If you've got one takeaway from the talk, don't ever watch this film. I'm only joking, but please don't. And in the 90s and 2000s, there's a huge market kind of convergence on OO languages. So Java 1 in 2001 had 28,000 attendees. That's like a rock concert, right? That's huge. That's crazy. A really nerdy rock concert. Popularity on the kind of web development kind of side of things kind of converges on a few simple concepts. So you see a lot of people using servlets, J2EE, using Spring, a lot of very OO concepts, a lot of very single mind of thinking. Things that are anything a little bit esoteric or have different ideas tend to kind of ramp down in popularity, die off a bit. Smalltalk, Lisp, Perl, not so strong. But nowadays, especially since Arnie's come back from politics, you see things start flipping back up again. So a lot of the established OO languages kind of becoming more multi-paradigm. So for Java, generics, kind of an idea that's very much come from functional research, kind of comes in the mid-2000s, and lambdas this year. Woohoo! And C++, again, also introduced lambdas in C++ 2011, and a load of the ideas in templating, also again, coming from that functional side. Newer languages are almost exclusively multi-paradigm that have been developed, right? So I think Clojure is the only thing that I can think of that isn't heavily multi-paradigm. So you see all like F#, Scala, Salon, Kotlin, all multi-paradigm will take best of both worlds. Things like Ruby, Python, and Groovy, which are all kind of ramping up in popularity to some extent, all have some OO and some functional usage. They can all be pushed both ways. And I think that's kind of where I'm going to leave it, with the idea that certainly on the language design side, people have become friends, people have come together a little bit more, and let's hope the developer communities can as well. So I'm happy to take any questions in a sec. I do have a book out on lambda expressions in Java 8. Was anyone at the book signing earlier today? A few people? Cool. If you weren't there, you can buy it online. That's me on Twitter, and that's my blog. So does anyone have any questions on that topic? Or any of the things I've mentioned in the talk? Russell.
I think you were a little bit unfair to Virtual Maya earlier on. When you were trying to say that classes should not be changed once signed off. Because you've got to remember it's in the context of design by contract as a methodology. And it was also the context of writing safety critical software, where if you change the class, the plane falls out of the sky and still 500 people.
That's an interesting point. I didn't want to imply that the guy wasn't clever or didn't have a point. Just that I think that whole idea of being finished, I mean, it's a fair point that if you're writing control software for airplanes, you can have a job that's finished, right? Once you can have a plane and it doesn't fall out the sky, okay, maybe you're done. For most people, they're not in that situation, right? They're in a situation where requirements evolve, there is... Yeah. Yep.
And the issue really highlighted with the some Fortran code that you're not allowed to touch, let alone recompile, because you have to have 10 years of verification in order for the reactor to restart.
Yeah. Again, it's a situation that would apply in control software, but not outside of that domain, right? Cool. Thanks. Does anyone else have any questions? Okay, well, shoot.
I was going to say, so you talked about how we seem to be moving towards a merging now of sort of they coexist functional and OO. But an alternative perspective is that we're just using languages like Scala as a bridging kind of mechanism towards functional, and that functional is too alien for most people, so we sort of have these steps towards it. So I just wondered what you think about that. As in, how we move towards functional, but things like Scala are just a big way from it.
So I'm not in any way an industry analyst, but as a professional software developer, I think you have to try and look at industry trends around you, see what's going on, and shape your own career, shape your own development style, that kind of thing. As far as I can tell, there's concrete data in terms of language popularity of things which are hybrid ramping up. There's no huge second wave of something purely functional popping up to the top. So if your hypothesis is correct, then in 10 years' time, the latest version of Haskell Prime will start kicking up that TOB index. I think until you start seeing that kind of data-driven trend, any attempt to read into it that there's a shift beyond what you have data available for seems to me a bit of, I don't want to say wishful thinking, but it's kind of like, interpreting the trend to go somewhere where you'd like it to go rather than where you have data to conclude that it does go. But yeah, I'm not saying it's necessarily wrong.
I guess part of why I say that is because where I work, we use Scala, we were JavaScript, and actually now we're talking about moving towards a very functional style of Scala. So I won't be talking about that. So I see that shift even within the language.
Yeah, it's a reason. As I say, I'm not saying you're necessarily wrong, but for me to draw that kind of conclusion, you would have to see that second wave of purely functional popularity ramping up, which, yeah. Okay, any other questions? No, cool, right. Thank you, you've been a great audience.